Here we got three routers with good adjacency, OSPF adjacency between these neighbors. And when I check, I can see the neighbors up. Show IP OSPF neighbor, I can see the neighbor. And when I go to router 1 and show the routing table of OSPF routing table, I can see I got a very clear route to reach from this loopback to that loopback. Now, authentication, by default, we see null authentication is enabled. Where can I see? You can debug and see. Let's say, no, there you cannot see. Show IP protocol. You will not see anything written related to authentication. No, nothing. Okay, let us see under the interface. Show IP OSPF interface F00. Even here, you don't see anything related to authentication mentioned. Okay? Nothing related to authentication mentioned here. So we are going to now see those things by debugging first, and then I'll capture a packet, and then I'll show you. I'll capture a packet first, and then I'll show you. First, let us do debug. Sorry, debug IP OSPF packets. You see, every 10 seconds, I am supposed to receive a hello packet and send a hello packet. I'm waiting for the 10th second. Look at this. I received one hello packet. And you see authentication is type 0. Type 0 authentication. Null authentication. I'm receiving a version 2 OSPF packet from the router whose router ID is 2.2.2.2. And the type of the packet is type 1. What is type 1? No. What is type 1? Message type 1 in OSPF? Hello packets. Hello packets. This is the chapter where we saw number 1, type. OSPF packet type is hello. 2 is database description. 3 is link state request. 4 is update. 5 is acknowledgement. So the numbers are not just serial numbers, they are packet type. 3 means link state request. Now let me also debug, use a Wireshark in between these two router, Wireshark capture, and I'll show you the authentication portion of OSPF. Wireshark is a very interesting tool that someone should master. If they are really learning or troubleshooting, they need to know Wireshark very well. Okay, let me first of all zoom this for you. I zoomed it for you, and let me adjust this for you. Here we go. I have adjusted it very well. And then let me bring the OSPF packets by filtering. How do you do that? I simply go to the filter and say OSPF. I got all the OSPF packets. And now I would like to show you by opening this layer 3 first. Please focus. Layer 3. When you go to the layer 3 header, you will see that the packet is an OSPF packet. And the protocol identification number is 89. So layer 3 also knows that I'm carrying a payload of OSPF. Which layer OSPF works? Which layer OSPF works? It works in layer 3. Please focus here. If you see this, this is layer 2. Ethernet is layer 2. You see the source and destination MAC address. Now in layer 2, it has got the information about layer 3. This is the one. It says the layer 3 is not IPv6, it is IPv4. And this is the type. 0x0800 means it's IPv4. That's the layer 3. And when you go to layer 3, you can see IPv4. And when you go down, it talks about what is next. Next is OSPF. It says the next header is OSPF. So you close this one, the layer 3, and you see OSPF. This is not layer 4. OSPF is not layer 4. You should not call it as layer 4 protocol because it is in the fourth line. This is the payload of, it's the part of, it's the data of layer 3. Layer 3 says in the protocol field, I am carrying the informations of OSPF. It is saying I'm carrying the information of OSPF. And what is that information? That is what here you see. OSPF, open shortest path first. And when you open the header, it says it's a version 2 OSPF. It's a hello packet. And the length of the packet is 48. You see, you saw exactly the same thing here. The length of the packet is what? 48. Received from where? The router ID 22222. It's exactly the same information you see here as well. And then the area ID is 0. It's 0 area ID. You can also see here the area ID is 0. The checksum value is BA79. And you can even see that, okay, see BA79 here after 0x. 0x here means hexadecimal. BA79 is the checksum value. And it says the checksum is correct, meaning no one tampered the packet in the path. And you see the authentication type is null authentication. Because null authentication, there won't be any intent. Yeah. So the authentication type is null by default. And this is also a type 0 authentication. A type 0 authentication. Both the side, the type should match. Both the side, the type should match. Wait, let me just go and refresh OSPF neighborship now so that I can show you some update packets. I'll go to router 2 and I'll clear IP OSPF process. As soon as I say hint, yes, I'll take you to the Wireshark. And look at this, I see some request packet, I see some update packet. Now, I told you database description is type 3. You see? Up, you see? Sorry, database description is type 2, request is type 3. You see? Type 2. If you want to see all the database description packet, then you need to drag and drop this to the filter and you will see only DBD packets. You open any DBD packet, you will see only type 2, type 2, type 2. Now, if you wish to see the LSR packets, change it as 3 here in the filter. You see, there's only one LSR, link state request packet. You see, LSR is type 3. All right, anyway, that's not the main story in our class today is authentication. But I want to show you that even the LSR will carry the authentication. Not only the hello packets, every single packet carries the authentication type. It can be a hello packet or a DBD or, let me show you again, the DBD packet or LSA packet. See, LSA acknowledgement also got now, so there are 4 acknowledgements. All 4 acknowledgement, if you see, it has got the authentication type. Now let me say message type 4, which is LSU. There are many LSUs. You take any LSU and go down, you will see authentication type again. So here I'm proving you that every single packet carries authentication, database description, hello packets. Every single packet needs to get authenticated on with the neighbor. But here, both the side authentication is successful because both side null authentication. I said that is also a type. So both the side null authentication is successful right now. But did you enable authentication? No, it's by default. Type 0 authentication is default. Null authentication is default. Now what we do is next we'll go and enable type 1 authentication. What is type 1 authentication? Plain text authentication. How do you do that? I want to have a plain text in between these two, and I want to have a ciphertext between these two. Is that possible? Yes, it is possible. MD5 authentication. Clear text authentications are considered to be type 1 authentication. Clear text authentication is type 1 and MD5 authentication is type 2. So how do we enable clear text authentication? Very simple. In OSPF, everything goes on the interface. Okay, let me first of all stop the debug. I've stopped the debug, but I did not kill the Wireshark capture. The Wireshark capture is still going on. Let it go. Now go under the interface and say IPOSPF authentication. IPOSPF authentication uh, type. IPOSPF authentication key. Okay, don't give any space after authentication. Put an hyphen. Are you with me? Yeah. And then give a key. I would like to call it as um, ABC 123. And then IPOSPF authentication. Enter. Boom. You see the difference? Here with hyphen, this is without hyphen. What does this mean? This means I'm enabling a clear text authentication. How do you know? Go to the capture and see. I want to show you all the packets that is coming from this source address. All right, I want to show all the packets that are coming from the source 10, 12, 12, 1. So let me filter out. Boom. Okay, you see now, go down and you will see authentication. What is this? Am I doing on the right interface? Yes, I did. Is the IP address 10.12.1.1? 10.12.12.1? Let me check. Yes, it is. I think it is the old one. I need to go to the down one. Click the down one. The down one. Ah, here you go. You see? I was clicking the older one. So it says that simple password type 1 is enabled, and you see, this is the dangerous part. It shows even the password. It shows even the password. So not good. Not good. Anyway, um, let us now change the source. Coming from router 2. Coming from router 2, and I'll go to the last line and see whether there is an authentication. There is no authentication. It's null. This is the reason why I lost the neighborship. Actually, I lost the neighbor with router 2 show IPOSPO neighbor. I don't have any more neighbor. Earlier, when I was pinging this address 33333 with the source 11111, I was able to ping. But now, no roots, no neighbor, no roots, so no ping. So what we need to do? Enable authentication on the next router. And a rich interface. Yeah, like me. IPOSPF authentication. This says that I'm enabling plain text authentication. Say I've just enabled plain text authentication, but no key. So if you go now and see the capture now, the latest packet, it shows that you have enabled the simple password authentication, but there is no password. Whereas the packet coming from 1 has got the password ABC. ABC 123. So I'm going to say IP OSPF authentication hyphen key ABC123. After I say that, I should see neighbor coming up. Look at this. The updates are going. The neighbor has come up. Everything is smooth now. Both the sides they got the same password, router 1 and router 2. So the passwords are matching. As a result, the neighbor has come. And if I go to router 1 and show pinging, I can show you. Now let us debug. Debug IP OSPF packets. I would like to show you how debug shows this authentication information. Okay, you can see here authentication type 1 is enabled. But in debug, you won't see the password. Only the Wireshark you can see the password. For security reason, Cisco never allowed the debug to capture the password. Though it is a clear text password, that field is not captured when you say debug. But Wireshark company, they use something called packet capture, PCAP. The pickup algorithm is designed to pick up even the passwords in the packet. Is it dangerous? It is not dangerous. You should have enabled MD5 authentication. See, Wireshark is very useful tool. It's not a dangerous tool. It's a useful tool for troubleshooting, but to an extent, it is also dangerous because it provides information such as password. But if you will have an MD5 authentication or encrypted password, it's not dangerous. So in a clear text environment, of course, when you allow someone to use the Wireshark, they will know your password. All right, now what I'm going to do, I'm going to stop the filter, sorry, capture here, and start capture between these two. I'd like to show you MD5 authentication. Yeah. Now the packet coming from router 3, when you go down under OSPF header, you don't see any authentication. Also from router 2, you don't see this is from router 2. This is from router 3. You see the router ID here 3333. Here it is 3332. Both have got null. Now let's go and enable MD5 authentication on router 2. The interface name is F01. Sorry. Interface name is F01. And I would like to say IPOSPF authentication. Look at this message digest. This enables type 2 authentication. But no password is given. You see, I'll go and look. It says I have type 2 authentication enabled. But did I give any password? No, but the null password itself is like this. This is the hash value with which the password will be ciphertext. This is the hash value. This is the hash value without password. Now let me put the password and you will see the hash change. IP OSPF authentication -key. I can use different password or the same password which I gave there. I gave that ABC123. Here I can say XYZ123. Now if you go and see, the ciphertext will not be the same. You say the ciphertext is changed with different value. Earlier it was different. It was starting with some C something. Now this is a cryptography. This is an encrypted one. And you see, not just the encrypted hash value goes, even the sequence number must match. The sequence number goes, the length of the ciphertext goes, The key ID, all these are supposed to match with the neighbor. Now, let me go and enable authentication on router 3, interface F00. You see F00. And we'll say IP OSPF authentication message register, no hyphen, and then IP OSPF authentication key. What is that? XYZ 1 2 3. Now, if you go back and check the hello packets from 3, and let me go to the last. Hello packets from 3, hello packets from 2. Hello packets from 3, hello packets from 2. Hello packet from 2. You see, this is the hello packet starting with 02. Let us wait for the next hello. You see, it's not the same. Why, Even though it's the same router, the hash value will not be the same. Every time it will change, because every time the sequence number will change. So the hash value is generated not just by using key ID and the password, even the sequence number is involved. So you will not get the same password all the time. It will keep changing on the same router. See, again, I'm showing you 0.2. It changed. So don't expect the hash value to match. It won't match. But the device which is enabled with the right password will know whether the password is correct or not with the hash that you receive. Because there's an algorithm involved. When it receives the hash, it is not going to literally match the hash with the local hash. It is going to run against the message digest algorithm, and then it will determine the real password. Okay, so this is MD5. Now, when you go on debug, let us debug and see debug IP OSPF packet. You will see here type 3 only. There is no ciphertext, nothing. Only type 3 it will show. You see? Sorry, type 2. Only type 2 it will show. And the key ID is 0 and the sequence number is 0. It won't show you the password. Yes? Of course, yes. But this is a hello packet. Hello packet sequence numbers are not maintained in the database. If it is update packet, even the update packet will send authentication, isn't it? That sequence number will match. Update sequence number and the database sequence number will match. For the hellos, there is no sequence number maintained in